Alright, so let's look at our offline password attacks. We have a couple of tools I like to use for this. The first one is John the Ripper. We just call it with John. And there's lots of different things that John can do, lots of formats. And John is cool because one, it will work with the formats we already have, and two, it'll automatically pick the format if possible. So for instance, we can put in our Windows XP password hashes. And I just opened the third terminal. If we look at Windows hashes.txt, and if we compare these to, go have them on the desktop, Windows 7 hashes.txt. Of course, we have different users, but one thing to notice is that with our Windows 7 ones, all of these third fields here are the same, whereas on this one, a lot of them are different. Like these two are the same. Maybe they have the same password. This one's different. This one's different. It starts out kind of the same, but it's not completely the same. And a couple of them have that same value that this one does. So what's happening here is, this is the username, this is the user ID, this is the LM hash, which is the old Windows hashing algorithm that was still used for backwards compatibility in Windows XP days. And this is the newer NTLM hash. So with Windows 7, we have LM hash off. So this is actually the blank LM hash here. So with Windows 7, we'll be stuck cracking our NTLM hashes, which are stronger and harder to crack. So if the user uses a solid password that is not based on a dictionary word and includes lots of complexity, so uppercase, lowercase, symbols, numbers, and again, it's not based on a dictionary word, and it's sufficiently long, we'll probably have a hard time, even with a good word list, getting that password out. Fortunately for us as password crackers, most people don't use passwords that are strong. So even though we only have NTLM here, we may be able to get some passwords out. Here though, when we have LM hash on, I can guarantee you we can get the passwords out. LM hash is completely broken. Even here on my virtual machine that doesn't have much memory, much CPU power, I can still brute force, so try every possible combination for LM hash passwords in a pretty reasonable amount of time. So we can say that we should be able to very quickly get passwords out for administrator Georgia James and secret. We actually don't know what secret's password is yet. So with this one, it's all going to be based on the strength of those passwords. So if Georgia Vitamin, Martin, Lisa, and James used strong passwords, we may not be able to get them out. Administrator as well. Is administrator's password the same? No, it's probably blank. Probably disabled. So the problem with LM hash is a few things, and there are slides on this that I encourage you to look at. It like breaks it all down. Basically, it truncates at 14 characters. It hashes 2 7-character values independently, so they're not based on each other, so your key space is really small. Also, it ignores lowercase letters. So if you crack the LM hash password, you'll actually have it in all uppercase, and you'll only have the first 14 letters, or 14 characters. So if they use a really long one, you could lose parts of it, but it's not too hard, based on what you get out with LM hash, to try all the combinations for correct case and get one. So let's try John on Windows hashes.txt. So let's just have it do a brute force. Again, Windows hashes.txt is our XP, so it will have LM hash on, so we should be able to brute force and not use a word list. So it looks like James's password is Georgia, Again, they are all going to be in uppercase here. Looks like secret's password is password123, and administrator's password is password, and George's password is password. So again, really fast there. So to get the correct case, I always just try, like I do, passwords.text, and then do like password123, password123. And I could put in more, but generally those are gonna get it. I said that George's password was password, right? So I don't need these password ones. So I just start out with like all lowercase. I could also do this with rules. We'll see some rules when we move into Hashcat. You can do that with John the Ripper as well. Have it try. And then what was the other one? Georgia. This is generally sufficient. So this time I want to have it actually crack the NT hash because we have that value there. So we just had it crack off of the LM hash, but we also have the NTLM hash. And we only have the NTLM hash on Windows 7. We do John and do -- format equals NT and tell it we want Windows hashes.text -- word list equals passwords.text. So it looks like we've got password for administrator, password for secret, password for James. It doesn't have one for Georgia, but it may be in the pot. Anything you've done previously, if you've tried those same hashes before, it'll actually not show anything that's old. If I do John show Windows hashes.text, but George's is lowercase. I'm not sure why it's not trying that. So it cracked everybody but Georgia. Weird. Maybe because it was the same one. So we can do the same sort of thing here. We did a word list, so we just told it to try everything that was in that word list. So we could do the same thing here with our Windows 7 hashes. So it's going to be desktop Windows 7 hashes.text. And we want the format equals NT. So it actually finds nothing with our really silly password list. But it should have. Isn't Georgia Viteman's password? Unless I put it as something else. Could have, possibly. Now I'm slightly curious. But anyway, while that's doing what it's doing, we can also use certainly a better word list. There's one, if we go to user share John, and we have password.lst. It's probably really long and I probably don't want to do this. It's worked out alright. So it's got some passwords in here. We could use a better word list. Oops. NT. Found the administrator was blank. It's disabled. And Lisa's password is actually football. So it found that. What it is missing by default here is it is missing anything that's got like numbers on the end and stuff. What we need to do to make our numbers, to make like the first letter capital, to turn like an A into an @ symbol, put an exclamation point at the end. The stuff that people do when they're trying to do passwords securely but still failing because they put football as the main part of their password. So I guess Georgia Vitamin's password is not in fact password, which I thought that's what it was, but it's not. So who knows what I set it to? We might have to crack it. I think in the setup instructions I told you to set it to password, so who knows. So again, we are going to have to try a little harder to get those ones with a little more complexity with numbers and symbols and things. So what we can do for that is actually use rules. You can use rules in John the Ripper. We'll actually look at rules in the next section. We're going to look at a tool called Hashcat. John the Ripper and Hashcat are both really good password cracking tools. I know a lot of people who like one or the other, so I think it's worthwhile to know how to use both. So we'll look at Hashcat as well, because you may work some places where they absolutely want you to use John, and some other places where they want you to use Hashcat, so it's certainly worth knowing both. So we'll look at that next and see that we can do much the same thing.